Welcome back to 15-Minute Discourse. Today we're diving deep into space-based solar power. So we're talking solar panels, but not on your roof in space. Collecting the sun's energy, 24/7 beaming it down to Earth. Is this futuristic idea really a viable solution for our future energy needs? To find out, we're going to look at some internal notes on energy security.
Okay.
A NASA report on the feasibility of SBSP, a thesis on the wireless transmission of energy, and even some historical documents on how this idea has evolved over time. Could SBSP actually deliver on its promise of clean, abundant energy, or will it stay in the realm of science fiction? What would it take to build and maintain these massive power stations in space? We'll tackle all of that and more.
The thing that makes space-based solar power so interesting is the ambition behind it. It's not just about adding another energy source to the mix. It's about potentially revolutionizing our whole energy infrastructure.
It makes you wonder what's gotten so many people and countries even interested in this idea all of a sudden.
Yeah.
Like, what's the big deal?
Well, one of the biggest draws is the unique advantage that space-based solar power offers. Unlike solar panels here on Earth, which are limited by weather and nighttime,
Right.
SBSP can tap into this constant flow of solar energy. So we could generate huge amounts of baseload power, the kind that keeps our lights on without the limitations we face down here.
Okay, so that brings up the question of energy security. And you've mentioned before that we need to be prepared for disruptions.
Right.
How would SBSP play into that?
Well, even if SBSP becomes our main energy source, we can't put all our eggs in one basket, right?
Right.
What happens if we're depending on SBSP and a solar flare disrupts transmission?
Yeah.
So a diverse energy strategy is key. Imagine a system with redundant SBSP infrastructure up in orbit.
Okay.
Significant investment in energy storage and robust emergency response plans.
So it's like having a backup generator for your house,
Exactly.
but on a planetary scale.
Precisely.
SBSP sounds incredible, but it also sounds pretty futuristic.
Yeah, it does.
Can you break down the technology involved?
Sure. It's a fascinating combination of cutting-edge technologies.
Okay.
You need super efficient solar panels, possibly even designed for the harsh conditions of space.
Right.
Then there's the challenge of wireless power transmission,
Uh-huh.
beaming energy back to Earth, potentially using either microwaves or lasers.
Beaming energy down from space. To be honest, that sounds a little intimidating.
I can see that.
Are there safety concerns?
Safety is definitely a major consideration. To receive the energy, we'd use special antennas on Earth called rectennas.
Okay.
And researchers are working hard to make sure that the transmission process is safe and controlled,
Okay.
whether it's microwaves or lasers. And of course, we need to think about how to actually build and maintain these structures in space.
Yeah.
That's where advanced robotics and in-space manufacturing come in.
So this isn't just a theoretical dream, is it? Are there countries working on making SBSP a reality right now?
Oh, absolutely. The global interest in SBSP is booming.
Wow.
Some countries are actively pursuing it.
Okay.
Japan has declared space-based solar power a national goal.
Wow.
Their space agency, JAXA, has a roadmap to commercialize it. China also wants to be a leader in this field. They're planning to launch a series of small and medium-sized power stations in the next few years, with a goal of launching a megawatt-scale station by 2035.
That's ambitious. It sounds like a new space race is on, but this time it's for clean energy.
It seems that way.
This isn't exactly a brand new idea, though. SBSP has been on scientists' radar for a while, hasn't it?
You're right. Early studies by NASA go back to the 1970s.
Oh, wow.
And more recently, we've seen some interesting demonstrations of power beaming. Caltech, for example, successfully beamed detectable power to Earth in 2023. So these advancements show that SBSP is becoming less science fiction and more science fact.
That's exciting. With any ambitious project like this, there have to be some roadblocks.
Of course.
What are some of the main challenges facing SBSP?
I'd say two of the biggest questions surrounding SBSP are, is it technically feasible and is it economically viable? On the technical side, even though many of the individual technologies have advanced, the challenge is integrating them into a massive complex system that operates reliably in the harsh environment of space. Think about deploying and maintaining these gigantic structures in space, ensuring the safe transmission of power, dealing with space debris.
You don't want to have a collision with your power station.
Exactly.
What about the economic side of things? Building a solar power station in space can't be cheap.
You're absolutely right. The cost of SBSP is a major hurdle.
Okay.
A large chunk of that cost comes from just getting materials into orbit. We're talking about potentially thousands of launches, which is very expensive. Even with reusable rockets like SpaceX's Starship, NASA's assessments using the levelized cost of electricity show that current SBSP designs are much more expensive than Earth-based alternatives.
So cost is a major roadblock. What other specific challenges could make or break SBSP?
So we were just talking about the economic challenges of SBSP.
Right.
And the fact that getting materials into orbit is a major cost driver.
Yeah.
But what if we could kind of shift our thinking and explore alternative solutions like sourcing materials from space itself?
You're talking about asteroid mining.
Exactly.
We touched on that a little earlier, but how realistic is that? It still feels a bit like science fiction to me.
It might sound futuristic, but it's a concept that's gaining traction.
Okay.
Companies like Astroforge are developing technologies to extract valuable resources from asteroids. Imagine mining water from asteroids and breaking it down into hydrogen and oxygen, which could be used as rocket propellant.
Okay.
We could also mine metals for construction.
So we'd create this self-sustaining ecosystem in space.
Yeah, kind of a space-based supply chain.
That's a pretty wild concept.
It is.
Even with asteroid mining, though.
Yeah.
What about the solar power generation itself? Are there advancements there that could help make SBSP more viable?
Definitely, the field of solar technology is always evolving. Researchers are making big strides in developing high-efficiency solar cells that can convert a much larger percentage of sunlight into electricity. So you could generate the same amount of power with fewer panels, which would directly impact the cost and complexity of SBSP systems.
Makes sense. Fewer panels, less material to launch. Are these solar panels designed specifically for space?
Yeah, you need specialized solar panels that can handle the tough conditions out there. Extreme temperatures, radiation, micrometeoroids.
Right.
But advancements in material science are leading to lighter, more durable, and more efficient solar cells that are made for space.
So we've got the panels generating power in space.
Right.
But how do we get that energy back to Earth safely and efficiently?
Okay.
Beaming energy through space still seems kind of mind-blowing.
It is pretty amazing.
Yeah.
This is where wireless power transmission comes in. Researchers are exploring two main technologies, microwave beaming and laser beaming. Each has its pros and cons. Microwaves are less affected by weather, while lasers are more efficient but need a clear line of sight.
We talked before about safety. How are researchers ensuring that beaming energy from space won't be a risk to people, wildlife, or aircraft?
Safety is the top priority. With microwave beaming, the power is spread over a large area. Power levels would be way below what's considered harmful.
To people and animals and planes?
Exactly. It's similar to the radio waves we use for communication, just at a different frequency and intensity.
That makes sense. What about lasers, though? Aren't they a lot more intense?
Lasers do carry more energy,
Right.
but researchers are developing really sophisticated systems, multiple layers of safety features.
Like what kind of features?
Well, things like beam steering technology to make sure the beam stays on target, and automatic shutoff mechanisms if there's any interference.
So it's like a fail-safe.
Exactly.
Yeah.
These safeguards ensure that laser power beaming is done with precision and safety.
Those safety measures sound promising.
Yeah.
I know some people are also worried about space debris,
Right.
especially with such large structures for SBSP.
Yeah, that's a legitimate concern.
Is that a big problem?
It's definitely something to take seriously. We don't want to add to the space debris problem.
Right.
But careful planning and design can help minimize debris during construction and operation.
Right.
And we can invest in debris removal technologies.
So cleaning up what's already there.
Yeah, and preventing collision.
So it's about being responsible with our space activities.
Exactly.
We've talked about the challenges and the potential solutions.
Right.
Could this really happen in our lifetime? Or is this technology generations away?
That's what's so exciting about this field. A full-scale, commercially viable SBSP system might be a few decades away, but the progress right now is remarkable. We're seeing a convergence of technology advancements, growing private investment, and increasing international collaboration.
So you're optimistic about the future of SBSP?
I'd say I'm cautiously optimistic. SBSP is a huge undertaking, no doubt, but the potential rewards are significant. Imagine a world with clean, reliable energy accessible to everyone,
Wow.
regardless of location or weather.
That's a powerful vision.
It is.
We've been exploring the potential benefits and the big challenges of space-based solar power.
Right.
I want to kind of step back and look at the bigger picture now.
Okay.
What are the broader implications of SBSP, both positive and maybe negative, that we should be thinking about?
That's where things get really interesting. SBSP isn't just about generating energy. It has the potential to really reshape how we think about space, impact the environment, and even transform the global economy.
Okay, so let's start with space exploration. How could SBSP influence our future in space?
Well, imagine SBSP as a catalyst for a whole new era of space exploration and development. Think about what we'd need to master to build and operate these systems in space. In space manufacturing, advanced robotics, even asteroid mining like we talked about earlier.
Right.
These are all capabilities that could be applied to all sorts of other space endeavors, from lunar bases to going further into our solar system.
So SBSP could pave the way for a more permanent human presence in space.
Exactly. It could drive innovation and investment in space infrastructure that benefits a lot of fields, not just energy production.
Right.
And as we get better at operating in space, it opens up new possibilities for scientific discovery, resource utilization, even commercial ventures.
Okay, turning to the environment, SBSP is usually presented as a clean energy source.
Right.
But are there any downsides we should be aware of?
Well, SBSP itself won't produce emissions when it's operating. We can't ignore the environmental costs of making and launching the components. That's why research into sustainable materials, reusable rockets, and on-orbit manufacturing is so crucial.
So minimizing the impact here on Earth. Are there any other environmental concerns related to SBSP?
There's been some discussion about the potential impact of microwave or laser beams on the upper atmosphere. More research is needed to really understand these effects and make sure that power beaming wouldn't mess up any delicate atmospheric processes.
Yeah.
It's worth noting, though, that any potential impacts would probably be much less significant than the damage caused by fossil fuels.
Right. It's all about weighing the risks and benefits with any new technology.
For sure.
What about the economic implications? How could SBSP change the global economy?
Well, SBSP could lead to totally new industries and global markets. We already talked about space-based mining and manufacturing, but think about the economic opportunities from building, operating, and maintaining these SBSP systems. It would create demand for skilled workers, specialized infrastructure, and international collaboration.
Right.
All of that could boost economic growth.
And the energy from SBSP would be a valuable commodity itself.
Absolutely. It could bring clean and affordable energy to regions that don't have reliable power. This could be huge for developing countries, allowing them to skip traditional energy infrastructure and pursue economic development more sustainably.
So SBSP could have a positive ripple effect across the global economy.
It has the potential to...
Are there any negative economic consequences to consider?
Well, as with any disruptive technology, SBSP could lead to job losses in traditional energy sectors. That's why it's super important to think about ways to retrain workers and create new opportunities in these emerging industries.
Yeah, to make sure the transition to clean energy is fair.
Exactly. We need to ensure benefits of SBSP are shared equitably.
Right, so no one is left behind.
Right.
Are there any other downsides or risks with SBSP that we haven't talked about?
One concern is that SBSP could be weaponized.
Oh, wow.
The ability to beam concentrated energy from space could be tempting for the military.
Right.
It's crucial that we have clear international agreements and regulations to prevent the militarization of SBSP.
So it's used for peaceful purposes. It's a sobering thought.
Yeah.
But an important one.
For sure.
SBSP really raises a lot of complex questions.
It does.
Not just about the technology, but about ethics, economic, global governance.
It's a great example of how technological advancements have these ripple effects that go way beyond the immediate use.
Yeah.
It makes us think critically about our future in space, our responsibility to the environment, and how we want to shape global society.
It's fascinating and a little daunting to think about how much SBSP could change our world.
I agree.
As we wrap up this deep dive, what's one key takeaway you hope our listeners will remember?
I think SBSP is a powerful reminder that we're living in a time of amazing technological progress.
Right.
It's up to us as informed citizens to have these conversations about potential consequences of these technologies, both good and bad. We need to work together to make sure these advancements benefit humanity and our planet.
Well said. This has given me a lot to think about. Thanks for guiding us through the complexities of space-based solar power.
My pleasure.
And to our listeners, thank you for joining us on this journey. We hope you found it as thought-provoking as we did.
Yeah.
If you enjoyed this deep dive, don't forget to like this episode and subscribe to 15-Minute Discourse
Yeah.
for more explorations of these fascinating topics that are shaping our world.